Hey guys, my name is Frank, and this is the Python Programming Video Log. Today, I'm going to write a little 2D shooter with a tile background, and basically, I'm going to write this thing from scratch in pure HTML5 and JavaScript. You're going to watch me write pretty much the entire thing, at least all the JavaScript anyway, and hopefully when you're done, you're going to learn how to write a little shooter just like this from scratch without any help. So if you learn anything while you're watching this video, go ahead and give it a like, because that really helps me out. Also, go ahead and subscribe if you want to see my other videos or my future videos. Anyways, stay tuned and hopefully you'll learn how it's done. So I already have the HTML, CSS, and a very tiny bit of the JavaScript written for this example. For the HTML, I just have some basic stuff set up. Inside of the style tag, I have the background color set to black, the body display to grid, height and width of the body are 100%, height and width of the HTML are 100%, and the canvas I'm going to align in the center of my document. So then down here in the body tag, I'm defining the canvas element and the script tag, which is going to hold all of my JavaScript for the example. The only JavaScript I've written is for the map. So this is my map. It has 16 columns and 16 rows. And now that you've seen everything, line 53 is the last one in the file, I can start on the actual JavaScript. So let me come in here and get a handle on my canvas context. So I'm just going to say var context equals document.query selector canvas dot get context 2D. I'm going to also go ahead and create the game loop, so function loop. I'm going to perpetuate it by saying window dot request animation frame. I'm going to hand in it itself, so it's going to call itself. Then I'm going to perpetuate it, or I'm going to start it actually by calling the loop function. Alright, cool. So next up, we're going to go ahead and draw to the canvas. So I'm just going to come in here and say context.fill, fill with the lowercase l, style equals the hex value for a mid-green color, context.fill rect 0 0 context.canvas.width context.canvas.height. And now when I save, I'm going to draw green to the canvas. Alright, and my canvas is centered as per my CSS, but I want my canvas to be a little more structured than that, so I'm going to go ahead and I'm going to make it relative to the width and height of the document element. So I'm going to say var height equals document element dot client height, and I'm going to say, let's see here, width is going to be equal to client width. So let's just change this right here. Then I'm going to copy these so I don't have to type them out again. I'm going to bring them into the game loop where we're going to redefine them on every frame just in case we resize our canvas, or our browser window rather. I'm going to go ahead, I'm going to get rid of the var. This way we're not redefining those. Not that it would really matter much, but don't need to have frivolous declarations when you don't need them. Then what I'm going to do is I'm going to come in here, and before I draw to the canvas, I'm going to say context.canvas.height equals height, context.canvas.width equals width. Alrighty, and then I'm going to save, I'm going to refresh, and as you can see, my canvas fills up the entire browser window now, but I'm going to add a little bit of a border around here. Doesn't even have to be that much. In fact, I think I'm going to make it 16 pixels. 32 is a little bit much. I'm going to come down here and make this 16. I'm going to save. And that's going to put a margin or a border or padding around my canvas element of 8 pixels on all sides. So 16 pixels top and bottom, 16 pixels left and right. But now as you can see, my canvas is centered because of the CSS, and it is constantly resizing on every frame of animation because of this bit of code right here, getting the height and width of the document element and then setting that equal to the canvas's height and width. Or actually saying the canvas's height and width equal to that. Okay, so now what we're going to do is we're going to go ahead and get our sprite sheet or a tile sheet loaded up. So I'm going to come down here to the bottom. I'm going to say Actually, I should define this up there. I'll move it in a bit. Tile sheet equals new image. Just going to create an empty image. Tile sheet dot source equals shoot.png because that's the name of our tile sheet. I'm also going to go ahead and say tile sheet dot add event listener load, and this is going to handle the load event when our tile sheet actually loads up. I'm going to make an arrow function for the event handler, and it's just going to say loop. So when our tile sheet loads up, it's going to start the loop function. And that's good because we don't want to draw anything. We don't want to call any draw functions that use our sprite sheet or our tile sheet if it hasn't yet loaded, because that would cause an error to be put out there, and we don't want that. So let's go ahead and refresh, see if anything's wrong. Nope, nothing is wrong. Let's go ahead and use our tile sheet. So I'm going to come up in here. Each one of these tiles is 16 by 16 pixels. Actually, before I come up here, what I'm going to do is I'm going to move this variable up to the top because I don't like having variables just hanging out at the bottom when all my variables are defined at the top. So I'm going to come up here. I'm going to paste that, move it in line with the rest of my variables, and I'm going to come in here and I'm going to say var tile size equals 16 because, like I said, each sprite or each tile is 16 pixels by 16 pixels in dimension. So I'm going to go ahead and save that, and now we can start drawing our tiles. So I'm going to go ahead and get rid of this green because we're not going to need it anymore. Actually, you know what? I'm going to leave it for now. What I'm going to do is I'm going to say for let index equal map.length -1. That's going to put us at the very last position in the map array of tiles, or actually tile values rather. I'm going to say index is greater than -1 minus index, and this is going to loop backwards through our map from end to beginning, and it's going to touch on every single tile value. I just prefer to loop through things backwards. It's just the way I do it, if you were wondering. It doesn't really, you could loop forward if you want to, it doesn't matter. Okay, so now I'm going to say let value equal map at index. I'm going to define a value for tile X, that's going to be the destination tile X, and let tile Y, that's going to be the destination tile Y. And now we're going to actually start drawing some tiles from the sprite sheet to the canvas. So I'm going to say context dot draw image tile sheet, that's the image we just loaded up. I'm going to say start at the value, spelled correctly. We're going to start at value multiplied by tile size. So if I get a value of 0, it's going to be 0 times 16. Inside of this tile sheet, this is going to be 0 times 16, it's just going to be 0. If I have a 1 tile, it's going to be 1 times 16 for the X position. That's going to put me right here at 16. If I get a 2, that's going to be 32. So 16, 32, it's going to be this tile for the X position. All the Y values are 0 because the top of my image starts at 0. So I'm going to come in here and I'm going to say for the next part, 0. Then for the width and height, it's going to be tile size and tile size. And for the destination, I'm going to have tile X, tile Y, and of course, tile size and tile size. All right, cool. So now we just need our tile X and tile Y values figured out. So that's pretty simple. It is just going to be the index modulus the number of columns in the map multiplied by tile size. That's going to be the X value. That's how we calculate X from a one-dimensional map. We're calculating the conversion from a one-dimensional position in an array to a two-dimensional position on the screen. And for Y, we're going to use math.floor index divided by columns times tile size. I'm not going to get into why the math for that works. I have other videos on that. But that's going to go ahead and it should draw my tiles. Okay, so there we have the tiles. As you can see, they do not fill up the entire canvas. So we're going to have to scale this image up in order for it to fill up the entire canvas, because right now I have a scaling canvas and I want my image to scale as well. So what I'm going to do to handle scaling is I'm going to define a buffer image, and I'm going to draw all my tiles in their natural dimension to the buffer. And then I'm going to draw that buffer to the scaled up canvas. So I'm going to say var buffer equals document dot create element canvas.getContext 2D. It's going to create a canvas. It's going to get its 2D drawing context. Down here at the bottom, and this is very important to remember, we're going to have to adjust the width and height of our buffer. So I'm going to say buffer.canvas.height equals tile size times the number of rows in the map, and that's 16. So if there are 16 rows in the map and each one is 16 pixels high, that's going to be 16 times the number of rows. It's going to give us the full height of this image here. Same thing for width. Buffer.canvas.width equals tile size times columns. It's going to give us our width, and just so we don't skew anything, I'm going to do buffer dot, let's see, image smoothing enabled equals false, and that's going to prevent our image from being smoothed, I guess. So basically that's going to keep our pixels looking really sharp. I don't think it really matters on the buffer because we're drawing a direct, there's no scaling here, but I'm going to set that anyway just to be safe. Now in here, what I'm going to do is, instead of drawing this in real space or real dimensions to the context of the canvas that's on screen, I'm going to draw this in real space to the buffer. And then down here, I'm going to draw the buffer to the canvas. So I'm just going to say context, or on-screen canvas context dot draw image buffer dot canvas, and I'm going to start at 0, 0, buffer dot canvas dot width, buffer dot canvas dot height. That's going to be the width and height of the buffer canvas. So that's the source rectangle to cut from the buffer or blit from the buffer. And now I'm going to go to the canvas. So I'm going to start at 0, 0 on the canvas. I'm going to have context.canvas.width, context.canvas.height. And you might be thinking, why don't I just get a scale value, or just a number that represents the scale between the buffer size and the final canvas size, and just use that to scale up my images with draw image when I'm just drawing my tiles? The reason for that is because of edge bleeding. So I'm not going to go into that, but basically the way it works is, if I scale up an image, it's going to pull in pixels that may be on the outside of the source rectangle for the image that I'm cutting out, and parts of my other tiles may bleed into tiles that I'm drawing. So I might have my tiles bleeding into each other if I don't use this approach. So that's the reason I'm using a buffer canvas. I guess I did go into it after all. But now you can see that my image is scaled up to the full canvas size. The only thing is that now it stretches with my canvas. So I have to put a clamp on how big my canvas can actually scale. This way I keep the aspect ratio of my tile map the way it's supposed to be. So the way I do that is I come in here inside of my game loop. I'm just going to go ahead and get rid of this green because we don't need that anymore. The background's going to be full. I'm going to say var min size, and min size is going to represent the minimum size of my browser window. So I'm going to check to see, is the minimum size height or is the minimum size width? So for instance, if this is my browser window's inner dimensions, obviously width is greater than height. So I would only want to scale this to fit the height. I would not want to scale this to fit the width, because right now it's scaled to fit the width and it's skewed. But it should be scaled to fit the height, and then it would maintain aspect ratio. So min size is going to be equal to compound if statement, which is just going to be height is less than width. If height is less than width, go ahead and set min size equal to height. If height is not less than width, go ahead and set it to width. So now my min size is going to be either height or width, whichever is smaller, and I'm going to go ahead and set this final context.canvas size equal to min size. So this is just going to be equal to min size, and this here is going to be equal to min size. So now when I save and refresh, now my canvas is going to be maintaining aspect ratio no matter how big my actual browser window is going to get. So no matter if I adjust for width or height, it's not going to get any bigger than the minimum dimension of the screen. If I shrink, it's going to shrink to fit the minimum dimension of the screen. In this case, it's height, and in this case, it's going to be well, it was going to be width, but I can't scale down anymore. But this is going to be the case of width. All right, so that is how we do our scaling. The next thing I want to do is go ahead and put a player object on the screen. So I'm going to come up here. I'm going to define a class called player. Const player equals function. It's going to take an x value and a y value. The width and height of the player are just going to be tile size, which is right here. That's 16, remember. And our image is also going to be 16 by 16 pixels for each one of those player sprites. He's also going to have a direction. I'm just going to call that D. So this dot x equals x, this dot y equals y, and this dot d equals d. I'm also going to have frame values for him, but that's going to come into play a little bit later. But actually, no, it's not, because I'm going to define it right now. So this dot frame is going to be equal to, let's see here. This would be frame 0, 1, 2, 3, 4, and 5. So his frames are going to be either 4 for left or 5 for right facing. So I'm going to say this dot frame is going to be equal to, actually, let's not even take it that far. Let's just say this dot source x equals 64, because I think that's where it's going to be. So this is 0, 16, 32, 48, 64. And then this would be, what, 80? 64 and 80? Okay. So he's going to start out facing to the left, so his source x is going to be 64, and direction is just going to be equal to direction. Cool. All right, so now we're going to come down here. We're going to define our player. We're going to say var player equals new player. He's going to have an x of 100 and a y of 100, and he's going to be facing, for now, he's going to face the left, because let's just make him face the left. All right. So now we have to draw the player, so we come down here after we draw our tiles, but before we draw our final buffer to the display canvas. I'm just going to say buffer.draw image tile sheet, comma, the player.source x 0, because all the y values from the source are going to be starting at 0 because they're all at the top of our image. I'm going to go ahead and pass in tile size and tile size. Then I'm going to say player.x, player.y, and tile size again. Also, another added bonus of using the buffer and context, or the buffer and display canvas technique, is that you don't have to worry about scaling any of the things you draw to the buffer. You only have to worry about scaling once to the final display canvas, and the draw image function takes care of it for you. The only thing you have to worry about is maintaining aspect ratio, and that's as easy as one line with an if statement and setting this up. It gets a little more complicated if your aspect ratio isn't 1:1, but really not that much. Okay, so let's see if I got that right. I'm going to go ahead and do this, and there he is. You can't really see him, he's kind of small, but he's right there, and he's facing the left. So the next thing I want to do is go ahead and add some movement to this guy. So I'm going to make him fall. I'm going to have to add some velocity to him for that. So this dot vx, velocity x, let's say. Velocity x is going to be equal to 0. This dot vy is going to be equal to 0 as well. And I'm going to give him a prototype with an update position function. So player.prototype equals an object literal, and that is going to have a function inside of it called update position function. This dot x plus equals this dot vx, this dot y plus equals this dot vy. Then I'm going to degrade vx and vy by something like friction, but it's just going to be artificial friction, so I'm just going to use 0.9. So this dot vx times equals vx, this dot vy times equals 0.9. I don't know what I was doing right there. 0.9, and this is just going to gradually decrease the amount of vx and vy, or velocity x and y, by multiplying it by just a little bit less than 1. So it just gets a little bit smaller on every frame update position is called, and that's going to make him appear to slow down as a result of friction. Alright, so now we have update position. So what I'm going to do is I'm going to save, and I'm going to use this inside of the game loop. So after we draw our tiles, we're going to go ahead and insert this right here. Player.update position. But first we're going to have to add to the player's y value. So player.y, vy plus equals 1. So this is going to make the player fall, and he falls. Next up, we're going to add some collision between the player and the tiles, but we're not going to do real tile collision. We're just going to estimate where, not estimate, but we're going to set a boundary where the top of this tile is, and he's going to hit it. It's not real tile collision. It is just a way to fake it. That's why I have one big straight line instead of interesting platforms. So what I'm going to do is I'm going to say if player.y plus tile size, and that's going to give me the bottom of the player, because remember his height is equal to tile size, which is 16. If player.y plus tile size is greater than tile size times, and I don't know how many tiles down this is, but this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the 11th tile down. 11 player.y equals tile size times 12, and I'm gonna have to tweak this a couple times probably to get it accurate. Yep, okay, so let's do 11, and let's make this 10. Let's see what happens there. Oh, a little bit closer. Let's go ahead and make this 10. Let's see about that. This is the tweaking process. Yes. All right, there we go. So if the bottom of the player is greater than a 160, or tile size times 10, player.y is going to be equal to 160. Perfect. But I want him to look like he's standing on the platform, and I'm pretty sure this is at 160. I'm not quite sure, but I think it is. So I'm going to go ahead and come in here and just add +4, and that's going to move him down a little bit. And you don't actually want to use raw numbers or raw values like this for your actual game code. This is just all very improvised. But as you can see, that just nudged him down a little bit, and it looks like he's standing in the center of the boardwalk instead of like on the very edge of it, and it just makes more sense that way. Okay, so now we have collision. Let's go ahead and add jumping. And you're probably like, what does this have to do with shooting? But this wouldn't be a very interesting example if you could just shoot a bullet from a stationary position. You want to be able to shoot a bullet from a moving position because your player is going to be moving. So let's go ahead and make the player move. I'm going to say, let's see here, context.canvas.add event listener click. I'm going to have an arrow function here with an event. Now the reason I'm using click is because I can get click to work on desktop and most browsers. iOS, I don't think accepts click, so on iOS this example is not really going to do anything, but if you have iOS, go ahead and check out the working example on a desktop computer, because I have not yet gotten an iOS device to test on, so I can't really test on an iOS platform, so it's kind of an issue for me right now, but I'll get around it at some point. Anyway, we're going to have a click listener, and what's going to be inside of the click listener is a pointer.x equals event.target, or actually event.page. Actually, you know what? Page x, pointer.y equals event.page y, and up at the top, I'm going to go ahead and define pointer. So let's see here, come in here, and go right above the player. I'm going to say var pointer equals an object literal with an x value, which is going to be 0, and a y value, which is going to be 0. So now these two coordinates are going to represent the mouse position inside of my world. So let me go ahead and add a function here to the update position. I'm just going to say x and y. This dot vx equals x minus this dot x. This is going to calculate the difference or distance between the x value of my pointer and the x value of my player. times 0.01. I'm going to say, no, I'm not going to worry about direction yet. So let's go ahead and test this out. Oh, looks like there's a problem here. Something has gone horribly awry. Let's see if I can figure out what it is. I'm just going to go ahead. Oh, actually, I know what it is. I haven't actually put a value into update position yet, so it's reading nan, and it's setting my player's position to something that is not a number. So let's go pointer.x, pointer.y. I'm going to refresh, and my player is going to gradually move towards my pointer where I click. The only problem with this is I have not adjusted my pointer's position for the scale of the world. So what I'm going to have to do is I'm going to have to come up here, and I'm going to have to get a value called scale. I'm going to start it out at scale equals 1, but scale is eventually going to be the scale between my buffer and my scaled up canvas. Oh, actually I grabbed the wrong thing there. There we go. So it's going to be the scale between the buffer and the scaled up canvas size. Just fix that real quick. Alright, so that's going to come into play right here. So I'm just going to say scale equals min size divided by, let's see here, buffer.canvas.width, I guess, because it's a 1-to-1 ratio, so I could either divide by buffer.canvas.width or buffer.canvas.height. So I think that's going to be a good value for scale. Let's go ahead and test it with console.log scale. I've got 1.42578125, so that's a bigger value. So the scale is going to be representing the value to multiply the buffer's width by to get the canvas's width. So let's go ahead and try to work with that. Don't need this console.log anymore. I'm going to get rid of it. I'm going to come down here, and I'm going to adjust this pointer by scale. But first, I have to also account for the offset between page X and Y, which starts at the top left corner of the screen, and the actual position of my canvas. So I'm going to go ahead and do that by saying var boundary equals event.target, which is going to be context.canvas, event.target.get bounding client rect. I'm going to say page X minus boundary.left. Boundary.top. Let's see what that does. Page X minus boundary.top is going to give me and then I'm going to do divided by scale. Divided by scale. Let's see if it works. If it works, the top left corner of the player should go to my mouse pointer. And it does. Look at that. Alright, cool. Very, very painfully slowly because of how I have the math set up. But it does work, and now my mouse pointer has been adjusted to enter a position into the actual real world space, even though I'm clicking on the scaled up canvas space. So there you go, pretty simple. If you want a little performance boost, you can get rid of this division and define scale differently. You could define scale backwards and say that scale is equal to buffer.canvas.width divided by min size instead, and down here you would get multiplied by scale instead. But whatever, I already have it this way. It's a minimal performance boost, so I'm just not even going to do it. Next up, let's go ahead and make the character jump. Just to make things more interesting, I'm going to go ahead and make the character jump. I'm going to give him a function called jump. And inside of jump, this dot jumping is going to be equal to false because he will have just jumped when this function is called. This dot vy is going to be equal to negative 20 because we're going to have him jump insanely high. And I'm also going to need to give him a value here. This dot jumping equals true because why not? Also, we're going to have to account for when he hits the ground. When he hits the ground, he's not going to be jumping anymore. So this right here if player.y plus tile size plus 4 is greater than tile size times 10, we are going to, actually this is probably, let's see if this actually works here for a second. Yeah, I think there was a problem with this. You want to also have this plus 4 on this side of the equation as well, but forget about that for now. That's a minor detail. And we're also going to come in here and say player.jumping equals false, because he will have just hit the ground if that if statement is true. Okay, so now I'm also going to come into my pointer. Before I can make him jump, I have to have a way to indicate that I'm inputting something with the click. So let's just say if pointer.down, then we're going to jump. So if the pointer is down, we're going to jump. And when is the pointer down? Every time we click, the pointer is down. So inside of the click event handler, we're going to say pointer.down equals true. I'm going to save that. Inside of the game loop, we're going to say, let's see, where are we? Right here. Inside of the game loop, we're going to say, in addition to gravity being added, we're going to go in and say if pointer.down, if pointer.down, player.jump, see what happens. Not working for some reason. If pointer.down, player.jump, let's see here. We're just going to do a little test to check to see if pointer.down is actually working. And it is. So instead of doing that, what we're going to do is say pointer.down equals false to stop it from being true. The problem seems to be lying inside of player.jump. So let's go over to player.jump and see what the problem is. Inside of player, we've got the jump function. This.jumping equals true. This.vy equals -20. I do not see the problem here. And do another quick test to see if the jump function is actually being executed. It's being executed every time I click. I'm not entirely sure why jumping is not working. This.vy equals -20. This.y plus equals this.vy. Oh, I think I know the reason. Let me go down here. Whenever you land on the ground, you have to set the player's velocity equal to 0. So let's go ahead and find that collision code in here. This is the if statement. If the player is hitting the ground, basically, we're going to go ahead and say player.vy equals 0, because you can't fall when you're already hitting the ground. And that still isn't cutting it for some reason. Let me see. Player.vy equals 0. Player.jump. Player.vy plus equals 1. Let's go ahead and see what we, oh, you know what? Maybe this is the problem here. Go up here. This is just going to be a bunch of testing until I figure out what the issue is right here. You know what else could be the problem here? Let me see if I can get this to work by just making this a really high value of 60. Yep. That works. So the problem is actually that my collision code is trapping the player inside the tile because I've written it wrong. So what I'm going to do is I'm going to go ahead and I'm going to correct the collision code. This way the player is not getting trapped. So let's see here. I'm going to start out at player's Y position, which is going to be the top of the player. I'm going to add tile size, and I'm going to not add 4. Let's get rid of that 4. So if the bottom of the player is greater than tile size times 10, let's see. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's greater than 11, actually, plus 4. So if it's greater than this right here, then player.y is going to be equal to tile size times 10. So if this is 11, then this is 10, plus 4. I think that's going to be good. And I also don't need to multiply by 60 or add 60, or rather subtract 60 to make the player jump a ridiculous distance into the air. That's already ridiculous enough. So I'm going to go ahead and make this 10. And look at that. I can jump as many times as I want. That's also a problem. So I'm going to go ahead and put an if statement in here. If not this dot jumping. So if the player is not jumping, then he'll be able to jump. So maybe we can only jump once. I don't know if you could hear me clicking, but I'm clicking and I'm no longer jumping. So now I have movement and I also have jumping. So now what I want to do is I want to figure out what direction I'm facing, and I want to face the player in that direction. That's the last thing we're going to do, I think, before we actually get to the shooting. So let's come in here and just say, let's see. If this dot vx is less than 0, this dot source x is going to be equal to what we said before, 64, because 64 is going to be the source x position of our player right here. That's 64 pixels from the left side of our image. And then 80 pixels is going to be for right. So let's go ahead and say else this dot source x is going to be equal to 80. So let's see what we get. We're going to have him facing the left if he's moving left, and right if he's moving right. Cool, cool. You know what else? I think I'm going to have him not jump if the mouse is below the level of the tiles there. So I'm going to come in here. I'm getting lost in my code. I'm getting too much code. If player.down, I'm going to say if pointer.y is greater than, what was that value? It was 11 multiplied by, actually I'm just going to do if pointer.y is greater than, or if pointer.y is less than player.y, player.jump. But otherwise, if it's not greater than player.y, he's not going to jump. He's just going to move. So down here, you're going to be able to move. Up here, you're going to be able to jump. He's jumping not really that high. Not sure why he's not jumping that high anymore. Let me go up here and adjust that real quick. Look at me, I'm tweaking my source code here, just having fun with it. I should be trying to progress towards the end so I can finish up the video. Alright, that's a stupid, ridiculous amount to jump, and that's good. So now he can move back and forth without jumping, and he can jump if you click up high, so that's great. Alright, so the next thing I'm going to do is I'm also going to come in here and set direction. So with the source position change, when he changes directions, he's also going to change direction. So this dot direction, or D, is going to be equal to -1. And this dot D equals 1 for facing right. Can't tell what's going on, but it's going to help when we start shooting our bullets. So next up, I'm going to make the bullets class. Const bullet equals function x, y, and that is it. Also, it's going to have D for direction, actually. So this dot x equals x, this dot y equals y, this dot d equals d. Bullet dot prototype equals an object literal. Inside of that, we're going to have a function called update position function. It is not going to take parameters. It's just going to go ahead and move the bullet. So this dot x plus equals, let's say, let's give it a vx as well, velocity x. So this dot vx is going to be based at 10. And actually, you know what? Let's add a vx parameter, vx, because if we're shooting while the player is moving quickly to the right or to the left, we don't want the bullet speed to be less than the player's movement speed. So we're going to add the default bullet speed to the player's speed. So we're going to hand in the player speed when we create our bullet to start. So this .vx is going to be equal to a base of, let's say, 5 plus vx. We're also going to do 5 times direction, because direction is either going to be -1 to go left or +1 to go right. And the player's velocity, x velocity, is going to either be negative or positive based on his direction as well. So that should be a good setup. So we're going to do this.x plus equals this.vx. That's our bullet right there. I think I'm getting everything. I'm not quite sure, but I could always go back and tweak it. I'm going to come down here. I'm going to create a bullets array. Bullets equals new array. Cool. And then I'm going to come down here and I'm going to go ahead and loop through all of my non-existent bullets. Actually, what I'm going to do before I even do that is if pointer.down, I'm going to go ahead and say, bullets.push new bullet, player.x, player.y. Let's do player.y plus like 4 or something like that to move the bullet a little bit farther down. And then I'm going to do player.direction and player.vx. Cool. So now I have a bullet in the array. It was just created with new bullet. Now under here, I'm going to go ahead and I'm going to loop through all my bullets. Index equal bullets.length minus 1. Index is greater than -1. Minus index. It's going to loop through my bullets array backwards. Let bullet equal bullets index. Bullet dot update position. And I'm sure that there's a glitch in my code somewhere right there. Oh, you know what? I'm not actually drawing any of my bullets. So I also have to draw my bullets. That's important. So buffer.fill style is going to be equal to black. That's a pretty good bullet color. Buffer.drawRect, or actually buffer.fill rect, and I'm just going to have bullet.x, bullet.y, and let's say 4 and 4. And that should do it for drawing the bullets. So let's go ahead and draw the bullets. Look at that. He is shooting away. He can shoot up high when he's jumping. He can shoot down low. The bullets are kind of not centered on the player. So what I'm going to do is I'm going to say, when I create a bullet, I'm going to say player.x plus tile size times 0.5. And that's going to center the bullet in the center of the player. I'm also going to do -2 because remember our bullets are going to be 4 by 4. So that's going to perfectly center the bullet on the player, hopefully. So let's see what that looks like. A little bit better. As you can see now, it's kind of in the correct position on either side of the player. But what I'm going to go ahead and do now is I'm going to say also add on to that the player.direction multiplied by, let's say, 4. And I'm also going to lower it on the Y position to be equal to 8. So let's go ahead and see what that looks like. All right, that looks pretty good. It's coming right out of the front of the gun there. So when I jump, I'm not only shooting, but it's coming out of the gun at the right location. And believe it or not, that's a pretty good way to do it. It's not too bad. So now the only thing left that you may not think of at first is when the bullet goes off the side of the screen, it hasn't actually been removed. It hasn't been garbage collected. It's still there moving to the far left or far right of the screen, and it has not yet been destroyed. So we have to, on every frame, check to see, is the bullet past a certain point? And if it is, go ahead and get rid of it. And this is a handy feature of looping backwards by default, because to splice an object out of array, it's better to be looping backwards because it does not change the length of the array that you've already looped through. So let's go ahead and say if bullet.x is less than, let's say, 100, we're going to say bullets.splice index, because we're already at the index of the bullet in the array, comma 1, and just go like that. So now when we shoot to the left, shooting to the right now, when the bullet goes to the left of 100, it's just going to be removed, and JavaScript will garbage collect it, and that'll be that. So what I'm going to do is I'm going to set this to be equal to if bullet.x is less than, and let's see here, -4 for the bullet's width. Remember, it's going to be a width of 4. So as soon as the bullet is all the way off the screen, it's going to be removed. We're also going to have to account for the right side, or bullet.x is greater than buffer.canvas.width. That's going to be our world size. Actually, let's go ahead and show that as well, -100. So we fixed for right, so it's garbage collected when it goes off the, or actually for left, when it goes off the left side of the screen, it's garbage collected. Now when it goes off the right, it's going to be garbage collected. There it is, getting garbage collected at 100, or removed. I don't know if it's being garbage collected at exactly that point, but now our bullets are going to be removed off the left and right side of the screen. All right, so that's it. That is how to shoot. I don't think I forgot anything, but I may have. So that's that. In conclusion, I just want to add that after I made the main content for the video, I did add this line right here, context.image smoothing enabled equals false. And the reason is because I wanted a nicer look. I didn't want that smoothed out look. So if I refresh here, you can see that it's kind of blurry. And when I add this line back in, you can see that it gets nice and unadulterated, and everything looks the way it's supposed to. So in conclusion, this is how to write a tiled background little 2D shooter, and hopefully you guys learned something. If you did, go ahead and like the video, subscribe to the channel. I'll have more videos like this coming out soon. As always, in the link, or actually in the description of the video, I have a link to the working example and the full source code on my GitHub. And I'm also going to throw a link to my website in there as well, just so you can see my other projects and whatnot. So go ahead and leave a comment if you have any questions, and I will get back to you guys in the next video. Have a good one.